Okay, so in this one, we are going to do the other direction of Proposition 36. And we're going to say that if we have it that we have this point D over here, and then we draw these segments with the following relationship, right? Then we can prove that this is indeed tangent. Now, to do this, draw, I don't know, D, A, B, C, D, E, D, F, tangent to circle E. And that's going to look something like this, let's say. And then, draw in FE. And you want to draw in, draw EB. And we could even draw DE. Okay, now what we have here is that we know that from the previous proposition that we have this relationship between DCA and DF. We know from proposition 36, we know that DA times DC, or AD times, is equal to the square on DF. But we're given that this, which I should have wrote AD times CD, okay, AD times CD, because DA is the same thing and DC is the same thing as CD, is equal to DF squared, right? So we're given this fact, right, that this is equal to BD squared. So in this forces, instead of me writing this, I can write, well, it's given to me, which is that it's equal to BD squared is equal to DF squared, which immediately implies that BD must equal DF. And then that means that this is the same thing as this. And then you can say EF equals EB, both radii. So this is the same thing as this, and then you could say DE is congruent to itself if you say reflexive. And then you have three sides. So triangle DFE is congruent to triangle DEB by side. And then what you should say is well, we know that DF is tangent. So DF is tangent by how we drew it, right? Tangent. And then we have that theorem that if it's tangent, it must be perpendicular to the radius. So we have DF is perpendicular to EF, which means, let's just say angle 1 or whatever. Let's call this angle 1. Angle 1 is right. Now, if these two triangles are congruent, then that means that at this angle must also be right. So, by CPCTC, angle 2 is right, and DB is perpendicular to the radius EB. but this implies dB must be tangent by our previous theorem. Must be. That again, what's the theorem? The theorem states that if it's perpendicular to a radius, then its tangent must be tangent. And now we're done. We proved the other direction.